Let's learn about functions on a set. A function on a set is a rule that assigns each element in the set to exactly one element in another set. As seen in the diagram below, an element from the domain X, in essence, the set on the left side has an image or represents an element in the Y. The way the element in Y is chosen is by a certain rule, or as we call it, a function or a map. In mathematical words, a relation from a non-empty set to another non-empty set is said to be a function if each element from the domain corresponds to an element in the codomain. Classifying the functions, we have one-one or injective function, onto or surjective function, one-one onto or bijective function. Let's see them. One-one or injective function. We say a function f from a to b is injective if f of x equals f of y implies x equals y for all xy belonging to a. In the diagram below, we can conclude that the function is injective and each element from the domain corresponds to only one image in the codomain. Also, in the diagrams on the right, when C and D have the same image, in essence 3 in B, then the function is not one-one and can be called as a many-one function. In short, when no two elements in the domain correspond to the same element in the codomain, then the function is one-one. Onto or surjective function. A function f from a to b is surjective if every element of b has a pre-image in a. Here, we can see that when all the elements in the codomain have a pre-image, then the function is onto or surjective. In short, a function is onto if codomain of f equals range of f, where range of function is the set of elements having a pre-image. One-one onto or bijective function. The map f from a to b is bijective if it is one-one and onto. Students need to know that for a function to be bijective, the domain and the codomain should have the same cardinality. In a sense, both the sets should have the same number of elements. Moving on, we have counting of functions. Let A and B be two finite sets having m and n elements respectively. Then total number of functions from A to B are n raised to m or order of B raised to order of A. Number of one-one functions from A to B, if n is greater than or equal to m, then npm, and if n is less than m, then 0. Where npm is number of permutation of n and m, and npm equals n factorial upon n minus m the whole factorial. Again, let 1 is less than or equal to n, which is less than or equal to m, then number of onto functions from A to B are n raised to m minus summation r equals to 1 to n minus 1 raised to r plus 1 ncr n minus r the whole raised to m, where ncm is number of combination of n and m, and ncm equals n factorial upon r factorial into n minus r the whole factorial. Now, Cantor's theorem. For any set A, there is no map from A onto the set P of A, the power set of A. Now let's solve some questions. If you have answered all the questions, you have understood the topic. Happy learning!